Leetcode 102 binary tree level order traversal. Yeah, level order meaning that we go horizontally like this, level by level. And it's a medium type problem, as you can see. And the only thing that is slightly difficult here is that output. So take a look right now before we read it on the right side and see that the output is in a form of lists of ints. Yeah, and if it was just a flat list of ints, and of course those ints are the labels here, the integers that we store inside the circles, or the nodes as they are called, then it would be just a pure what? A pure BFS. Yeah, since BFS goes layer by layer or level by level, and because we have to create those inner lists, that will complicate a little bit. Yes, just slightly the raw BFS implementation, and that's more or less it. Yeah. So in this case, we usually ask, or I ask myself, and also when I do those videos for you, I try to give you those ways of thinking about those problems. When should we use which traversal? When should we use which algorithm, and so on? And sometimes there is a clear advantage of DFS, and in this case, it's a clear advantage of BFS, yeah, because BFS goes exactly layer by layer. And let's read the description, which doesn't tell us a lot, but let's read it. Given the root of a binary tree, yeah, root is an object of that class, tree node, where we store the value and the connection to the left and right nodes. Yeah, so we only store the connections going down to so-called children. Return the level order traversal of its nodes values here from left to right, level by level. Yeah, and also not only level by level, but we also have to start with the left. And here is an example. You can ignore the input since the input is not the real input. Yeah, it's just like some fake representation. And in real life, we'll be working with the objects of this class, and here are just integers, but the output is the real output. Yeah, so for example, here the first level is 3. Yeah, 3, and that's the only thing that we have here. Then we have 9 and 20, and those are those inner arrays or inner lists. Yeah, 9 and 20, and then 15 and 7. And the second example, of course, some edge case, we just have a single node, and then only that node has to be returned. And the last edge case is that the root itself is empty, so nothing is there, and there are, of course, no children at all. Yeah, so now let's copy that. And let's think about this for a second, just very quickly. And let's make it like this. Oh, no, final. Like this, 3, 9, 20, 15, and 7. That's our tree. And we want to have level order traversal. And of course, whenever we want to search or to traverse a tree or a graph, then first two options are DFS versus BFS. And of course, DFS is the depth first, so we go as deep as possible in one direction and then backtrack and try to go as deep as possible again. And BFS is level by level. So here, clearly, we want to use BFS. And to implement a BFS, we want to use an additional container. And it's usually a queue. And DFS uses stack or just recursion, and the stack is implemented behind the scenes. Or in case of BFS, usually we use the iterative version with some additional container, a queue, where we put all the neighbors of the current nodes, and then pop from the front. And that's it. That's the whole philosophy of BFS. Yeah, so we use some additional container. Let's create it here. Let's call it queue. Like this. We put the first element here. That's 3. Then we pop it. And when we pop it, then we take the children. So maybe let's do it in a tabular form, since we will lose track of how it was before. We have the queue, and we will have the children. And let's make it like this. Yeah, so first, of course, we start from the root. Then we pop the node. And current node is like this. Then we take the children. Children are 9 and 20. Let's make it a bit bigger to fit everything like this. Yeah, and we add children to the queue. That's it. That's the whole philosophy. Yeah, so 3 has been already used. So now we add 9 and 20. And then we pop current node as 9. Yeah, what are the children? No children. So we don't add anything to the queue, and the queue currently has just 20. Then the current node is 20. And that's it. What are the children of 20? Are 15 and 7. Yeah, and the queue right now removes 20 since we popped it here, and we add 15 and 7. And of course, for both of them, we will have no children, and first 15 and then 7. Yeah, and we continue this process until the list or the queue is empty. And at this point, the queue is empty, and we went through 3, 9, 20, 15, and 7. And if you take a look here at the output and compare it with our BFS traversal, then you can see that the numbers are in order. But the complicated or modified thing is the case of those inner lists. Yeah, so here we go. We just using row BFS, but we will have to somehow gather those values not in a flattened form, but in a form of those nested lists. Yeah, and that's the only complication that we have. And each time, let's make this nested list. So let's try to implement it. Let's create the queue. In Python, we use dqueue. And for each level, we will put them inside an inner list. Yeah. So normally we will put them flat, but right now we have that level order traversal, so we have to differentiate between the levels, and that's why we use this nested. Oh god. nested structure. And now we go with the loop. So while q current nodes, because right now it's not a node, it's just a list of nodes. In the first case, it will be just a root, but then we can have more than one node in a row. Will be q pop left, and we pop from the left, and then we create two rows. One row for the q and one row for the answer. Since we'll have to update the queue if there are more children, and we also have to somehow create an appropriate answer. So let's start the list here, and let's use the same way for list creation here and here, and that's it. And now let's go for each node, for node in nodes. If not node, continue. And if it's empty, we don't want to do anything with it. But if it's not, then we add to the answer, row answer, append node value. And value is just val. And that's here. And for the queue, we will extend it with both children. Node left and node right. And this is meaningful, so we always want to start from the left, since this is our requirement, left to right. And the next thing is, of course, after we have traversed or iterated through all the nodes in a given row, we will update if row q. We will update the queue itself, and we will also update the answer. Or the result, maybe, using this row. Okay, and that's it. Then we return the answer by the end. Let's run, and now let's submit. And we beat just 30%, but if we rerun, now we beat 100% and 87% with memory. That's because whenever they create very little test cases, those results are very chaotic. And in order to have more reliable results, we have to have more test cases in our tests.